All right, so for the reading for today for science, go ahead and have that ready to go, and then we'll look at the science workbook answers here. You'll actually have that answer sheet out if you have the back side of what you did yesterday. And so on page 1, on 81, you did yesterday, you should have 82. In 82, you have a chart there that talks about the different layers of the atmosphere, and that's what we're going to be talking about in the reading. So look at page number 114 and follow along as I read. And then when we get to the chart that is on page number 116, that'll show you the different layers of the atmosphere. Okay, Daniel, just leave the camera alone. Okay, do you understand? Andre, why are you sitting sideways? They can't see you anyway, it's past you. Some of you are so vain. Okay. There are many parts of weather other than storms. These parts are important as well. God has given people the ability to observe weather and learn about it. The weather that we observe takes place in a protective layer of air that surrounds the earth. Atmosphere. In the beginning, God created an atmosphere, a thin blanket of gases to surround the earth. If the earth were the size of an apple, the atmosphere would be similar to the apple's skin. So you can imagine that's pretty thin, actually, in comparison to how thick the earth is. So it lets in the right amount of energy from the sun and provides the air we breathe. It also prevents extreme weather differences on the earth. Contents of the atmosphere. One part of the atmosphere is air. But what is air? Air is a mixture of nitrogen, oxygen, carbon dioxide. Does anybody have an idea of exactly, well, I guess it gives you percentages there, the amount of oxygen that's actually in the air? We think we need to breathe oxygen. Oxygen is actually very explosive. It actually is very explosive. In fact, for fire to happen, you have to have oxygen. That's part of the ingredients. You have oxygen, you have heat, and you have, those were the two things, oh, and fuel. You have to have those three things in order to have fire. And so oxygen is part of that, but you get the oxygen from the air. Anybody ever have a grandparent on oxygen tanks, where they have to use oxygen tanks to breathe? If you notice that around them, they'll have a warning sign on them, do not use near fire, or make sure there's no fire. Oxygen is very explosive. 100% oxygen is a very explosive gas, and so that's why God put it so that it was mixed at the right percentage of what we breathe. We breathe more nitrogen than anything else. So, yes, sir?
But do we also breathe oxygen?
We do breathe oxygen. We breathe all those things. There are other gases, including carbon dioxide, that's the 1%, but nitrogen is the largest one. But our body needs the oxygen more than anything else. That's why if you're sick or if somebody's having a hard time breathing, the number one important thing is the oxygen that they need for their body to be able to, the cells to survive. So the body exchanges them through the lungs, the oxygen, and then gets rid of the rest of it, which comes out as carbon dioxide. So, yes?
What is carbon dioxide?
It's a gas. It's a gas that has one carbon atom and 2 oxygen atoms. Or is it dioxide? No, carbon dioxide. Yeah. So it's 2 oxygen atoms, and so it's when your body processes, your cells process the oxygen and it uses it. What comes out is sort of like the waste that comes from it, and that's what it comes out as is air, gas like that. So yes.
So the atmosphere isn't that thick?
Not in comparison to the size of the Earth. The atmosphere is actually very thin. Now for us, of course, as human beings, we're very small on the Earth, and so that the difference is that we look at it and we think it's really high because compared to us, we're very tiny in comparison to that. So, all right, yes.
So if you release oxygen by like fire, does it make it like more evident?
Does it make it more evident?
No, like just is there like more fire?
Oxygen is just very explosive, so in and of itself. But when it's mixed with something else, it's not as explosive. But when you have a fire, for instance, what it does is it takes the oxygen from the air to cause the fire to happen within whatever you're burning. So you have fuel like a wood. You set wood on fire like in a fireplace or on a campfire, and you start the fire. It has to have the heat. That's where the heat comes from. Like when we did the thing out there with the marshmallows, we had the fire pit, and the fire pit was able to have the newspapers and the dry wood that gets really hot and burns very quickly because it's very dry. And so that was the fuel, but it had to have the heat from the newspapers. The newspapers heated up that little bit of the really thin wood. That heated up really fast to get the larger wood heated up. But all of them used oxygen to be able to burn. If you had no oxygen, you would not have fire at all. There are certain things that will burn without oxygen, but for the most part on the Earth, what we have to burn needs oxygen to do that. if you've ever anybody ever seen any kind of safety things where you are looking at how to put out a fire in a kitchen, for instance. One of the things they tell you for an oil fire, if you have oil in a pan, anybody ever seen that before happen, a pan fire? Okay, so it'll pop up. If it gets too hot, the oil will just will combust. It'll catch fire because it's hot enough. It doesn't need a flame, it just needs the heat. So they tell you to take a wet rag and put it over it. That smothers it. It takes the oxygen out of it. That's why it will work. Okay, and so it's not, you have to either get rid of the oxygen, get rid of the heat, or get rid of the fuel. Those are the three things that you have to get rid of. You have to have all three in order to have fire. But let's go back to this now. All right, so it says, we cannot see or feel these gases. God provided the kinds of amounts of atmospheric gases to support the kinds of life He created. Plants need the nitrogen and carbon dioxide to produce food. People and animals need oxygen to survive. Providing an atmosphere with this blend of gases is one way God meets the needs of living things. Another part of the atmosphere is dust particles. When you clean your bedroom, you probably stir up dust. Dust particles may seem annoying when you're cleaning, however, they are useful in the atmosphere. Dust helps water droplets and ice crystals in the clouds form rain, snow, and other types of precipitation. Also know that a lot of dust that you have, that you breathe, that you touch, are basically dead skin cells from people. So, yes, believe it or not. And Angelica just about threw up. So, all right, air pressure. Let's look at the next part. I won't dwell on that, so Angelica can live through the rest of the day. Gravity pulls the atmosphere close to the surface of the earth. At any moment, there are thousands of pounds of air pressing on you. The weight of the air is called air pressure. Near the surface of the earth, the atmosphere presses down on each square inch with 14.7 pounds of weight. It does not seem that air would weigh very much, but there is a huge amount of air above the earth. As the air is pulled toward the earth by gravity, it increases the pressure. Air pressure is greatest at the surface of the earth and decreases as you move away from the surface of the earth or gain altitude. Altitude is the measurement of the distance above sea level. You'll need to know that word, altitude, because that is part of one of the worksheets you have. But you need it's the distance above sea level, okay? Not just above anything, but just above sea level itself. They use that as zero, basically, on a scale. Below sea level, of course, would be negative, or minus, like 600 feet below, I think, is the salt, no, what is it called? The Dead Sea is 600 feet below sea level. So that's pretty far below sea level. The altitude affects air pressure. There is less air pressure on a high mountain than at seashore. However, altitude is not the only factor that affects air pressure. Other factors, such as changes in temperature, also affect air pressure. One of the tools Isaac Klein used at his weather station was a barometer. A barometer is an instrument used to measure air pressure. Knowing the air pressure is important when forecasting the weather. Changes in air pressure may mean that a storm is coming. Pilots are also alert to changes in air pressure because the changes can affect flying conditions. Now at the bottom there, it says some places in our body, such as our lungs and middle ears, are filled with air. And some people's heads too, right? It says when we breathe in and out, the air pressure in our lungs change to equalize the outside pressure. Our inner ears are often closed, however. This means the air pressure inside our ears may not be the same as the pressure outside. The inequality may cause our ears to hurt as we travel up and down mountains or fly in a plane. How many of you have experienced that before, where your ears need to release pressure? Especially younger kids have a hard time with that. They really struggle to equalize the pressure on their own. To help prevent this, God has designed our bodies with a tube that goes from our middle ears to our throat. When we swallow, we open the tube and allow the air pressure inside and outside our ears to equalize. Did that gross you out too? Oh, I didn't know. Because sometimes things like that. Oh, by the way, a good way to think about the air pressure also. How many of you like swimming? So if you go swimming and you go into the deep end of the pool and you dive for the bottom, then you feel all that pressure of that water on you. That's like it is with air. But see, our bodies are built, God created us to be on the surface of the earth. So we get used to that. Now, can you get used to higher levels? Yes, you can. Colorado, Denver, Colorado, they call it the Mile High City because it is actually a mile high in the clouds. Well, that's high enough to actually have less oxygen there. It's a thinner air, less air pressure as well. So when people go up there, they can tell the difference. It's harder to breathe because there's not as much oxygen because it's higher up in the altitude. And when people who live there come down, they feel like they have more oxygen when they come down, as long as it's a city that's clean air. But basically, it's better for them. Look at the next page. So this is where you're going to fill in the sheet that you have there. So we have the layers of the atmosphere, and the very top one that you have there on your sheet, which is, what does it say there? I'm trying to see, what is the level? Let me just get my book. I'll get my book. All right, so on page 82, you have, it says, complete the organizer with your teacher. And so this is the first part that we're going to talk about there is starting from the bottom. And so we're going to start from the bottom. And that bottom layer is called the troposphere. So it says, God designed the atmosphere to have several layers. Each layer is different. Together, though, these layers protect the Earth and give it a controlled climate. The troposphere is the layer in the atmosphere that is closest to the Earth. But even the tallest mountain on Earth, Mount Everest, reaches only partway into the troposphere. About half of the air in the atmosphere is in the troposphere. The troposphere is also where weather occurs. The air in the troposphere holds in the radiant heat from the sun. This helps keep the surface of the Earth warm. At higher altitudes, the air in the troposphere gets thinner and colder. Just as a thin sweater cannot keep you as warm as a thick coat can, the thinner air at higher altitudes cannot hold as much thermal energy as the denser air near the surface can. So, if you look there on the troposphere, on this bottom layer is what you should have, the troposphere. Okay. Now, in that, you could put a couple of things in there with it. Don't just put big words, troposphere. Okay. You need to put definition also. Definition is that has half of the air, and most weather occurs there. Okay, so those two things you need to understand about the troposphere in particular. Okay, has half of the air that's in the atmosphere, half of the air, you just put half the air if you want, and most weather occurs in this layer. And you can see there, they sort of show you a picture of, because this is in kilometers, a picture of where Mount Everest would be in the troposphere. It doesn't even go up into the next layer, really. So, even though it's the highest mountain on the Earth. All right, page number 117 now. So weather is the condition of the atmosphere at any moment in time. That's an important definition to remember. That will be one you'll be asked on a test or in a quiz too. The troposphere contains many particles and water droplets that affect the weather. The particles reflect light, allowing us to see colorful sunrises and sunsets. The stratosphere is the next layer. So the next layer up is stratosphere. It is the next layer above the troposphere. The air in the stratosphere continues to get thinner as you travel away from the surface of the Earth. Unlike the troposphere, the stratosphere increases in temperature as the altitude increases. God made the stratosphere to protect the Earth. So that's one thing that you're going to put in there is it protects the Earth. And then during the day, the stratosphere shields the Earth from the harmful effects of the sun. At night, the stratosphere helps hold in the heat. So that's the second one. So you can talk about in the protection, it protects from harmful effects of the sun, and it keeps in the heat at night. For which one? It basically, you can do these two things. It protects the Earth from harmful rays from the sun, and the next one would be that it keeps the warm air in at night. Not a lot. I mean, it does get colder, but not like it would if it wasn't there. The third thing about the stratosphere you need to know is that the ozone layer is in the stratosphere. You can just say it contains the ozone layer. The ozone layer is the upper part of the stratosphere. Ozone is a form of oxygen. Molecules of ozone have 3 atoms instead of 2, as in normal oxygen. The layer of this gas is one way the stratosphere protects the surface of the Earth from the sun's harmful rays. The higher layers of the atmosphere also, well, we'll do the next one. Do you have a question, Matthew? You just scratching up. Yes, ma'am. Could not hear you. That's me. For the troposphere, there's not a definition. There are just things you're supposed to write down about it. There were 2 things I had given you. You'll have to come back and ask later. I don't want this video to go too long for Daliana. So, but we'll continue on here. The third layer up, this is the next one. It says the higher layers of the atmosphere also help protect the Earth. Meteors heading toward the Earth burn up in the mesosphere. That's the next one up, the mesosphere. All right, that's where the meteors start to burn because it starts to get friction against the elements of the atmosphere. And it says these burning meteors are the shooting stars we sometimes see. Anybody who's ever actually seen one? All right, live. Okay, so if you haven't seen one yet, you will get a chance to most likely one day. It's a little harder in Seattle area. when there's light, because it has to be a pretty bright one to be able to see it. But I've seen some really bright ones before, so it's not an impossible thing to do. Many of our weather and communication satellites are in the thermosphere. So in the mesosphere, you would put meteors burn there, or this is where meteors burn, or this is where shooting stars are. And then for the thermosphere, which is the next one up, the second to the top one, or second from the top, that's where our satellites are. Satellites are in the thermosphere. And then the exosphere is the very top one. It's a layer atmosphere farthest from the Earth. And this is where space and our atmosphere basically mix. So the atmosphere and space mix in the exosphere. They don't really mix. You don't get space on the Earth because it comes into the Earth. It's just that that's where that transition is between those two. Yes, sir?
Atmosphere and what?
In space. Yes, ma'am.
What was the thermosphere?
Thermosphere was the satellites. Communication satellites are in the thermosphere. All right, now, some people compare the atmosphere to a greenhouse. A greenhouse is a special building, often made of glass. It completely surrounds and protects the plants inside from extreme heat or cold. The sunlight, temperature, and moisture inside a greenhouse are carefully adjusted to provide the ideal environment for the plants. In a similar way, God designed the atmosphere to completely surround the earth. He planned for the atmosphere to protect the earth and provide the proper weather needed for each area of the earth. All right, so that's it for our video. And Daniel, can you stand up and hit the stop button on that, please?